welcome back to Explain 4. So we'll be going over finding the inverse of a cubic model. So it's kind of like a word problem with to the third power cubic expressions. So it says the function of v of r equals 4/3 pi r to the third, which gives the volume of a sphere, like our globe, given the radius. Find the inverse to r of v to find the radius of a sphere given a volume. So first things first, we know that this is a not quadratic but cubic function because it's raised to the third power. And what we're going to do is we're going to find its inverse. So we're going to, instead of writing v of r, we're going to write v instead. And the first thing we're going to do is we are going to get rid of the coefficients of r to the third. And what we're going to do for that one is we're going to divide both v and this side of the equation by, just as it says here, 4/3 pi. Okay? And just so you know, whenever we divide by a fraction, we are actually multiplying by the reciprocal. Okay, so what is the reciprocal of 4/3? 3/4, right? So that'd be 3/4. And we're still dividing by pi. So that would cancel that out, and that would cancel this out. And we're left with r to the third equals 3v over 4 pi. And we're then going to, just like as we got rid of something that's squared, in this case, if something that's squared, we got rid of it by square rooting. We'll do the same thing. We'll get rid of something that is cubed by cube rooting both sides. So that would be r equals the cube root of 3/v times 4 pi. And we're just going to rewrite that so that it is r of v equals the same exact thing. We're going to just copy it right on down. And essentially the inverse function would be, again, we're copying it down for, yes, a third time, the cube root of 3 times v over 4 pi. Alright. In this next one, we are going to, now that we've finished finding this, we'll go ahead and do the problem in your packet.